Hello, a great welcome to this presentation. Today we are going to discuss a very interesting topic, that is how to develop PM interaction diagram for column base plates. So as usual, let us start with introduction. So a PM interaction diagram for a base plate is a graphical representation of its design resistance to withstand various combinations of axial load P and bending moment M. A typical PM interaction diagram is shown on the right side, wherein you will find that along the x-axis is plotted the axial load P in kilonewton, whereas along the y-axis is given the corresponding bending moment M in kilonewton meter. So each point on the PM interaction curve corresponds to the design resistance of the base plate expressed in terms of a unique combination of a PM. For example, looking onto this interaction curve, let us discuss the two extreme points. For example, the point on the left side on the x-axis represents a pure tension case, whereas the point on the right side on the x-axis represents a pure compression case, and all other points are associated with a P with some amount of bending moment M. Thus we conclude that the curve serves as a failure envelope and is a powerful tool for designers to quickly verify the base plate by simply checking if the applied loads fall within the curve. So let us discuss the problem statement. So the typical column layout that is considered for this tutorial is given here. So and the parameters are listed on the right side. As you can see that the column section is HE A300 and the base plate is of grade S275 with a corresponding yield stress of 275 MPa. The plate thickness is taken as typical 20 mm. The width of the plate BP, that is a 420 mm, that is nothing but 2 into 150 plus 60, that's equal to 420 mm, and the depth of the plate HP is equal to 410 plus 2 into 60, that is equal to 530 mm. The number of anchor bolts considered for the study is NB is equal to 6. As you can see that 3 numbers are distributed on each side of the flange, and the diameter of the bolt D0 DB is taken as 20 mm. We considered class 8.8 anchor bolts for the study with an associated yield strength of 640 MPa and an ultimate tensile strength of 800 MPa. The bolt length chosen is LB, that's 400 mm. The foundation offset that is considered is equal to a length of 500 mm on each and every side of the plate. We considered that the base plate will be supported directly on a mortar joint of thickness 20 mm. The concrete grade for the pedestal is taken as C2530. So the construction of the axial load PM interaction diagram can be done in two ways. First thing is that you can make a quick hand calculation, or there are many FEA tools available here. For the present study, we constructed the PM interaction diagram using the CBFEM tool IDEA StatiCa. It shall be noted that for any project, the development of a standard base plate drawings along with the development of the PM interaction diagrams improve not only the design efficiency but also it results in a significant savings in time. So for this presentation, essentially we have used 3 documents. The first one is EN 199318, it's the Eurocode 3EC3. That is a design of steel structures, design of joints. And the other one is basically EC2, that's EN 199211, design of concrete structures, general rules and rules for buildings. And the third one, and it's also most important one, is EN 19924, that's the design of concrete structures, part 4, design of fastenings for use in concrete. So let us start with the IDEA StatiCa model. Okay, so this is the IDEA StatiCa 3D model for the column base plate. So we need to input a number of parameters to populate this model. So let me just show you some of the parameters. For example, going to the members, and pressing the column, you'll find the various properties associated with the column. You can see that the column cross section is HEA300, and that we have used an orientation angle gamma of 90 degrees to orient the member properly, and the model will be taken as a NVY-VZ MX-MY-MZ model, and all the forces will be considered in the node. Now coming to the base plate, here we need to input all the parameters that is required to define the base plates, the anchor bolts, its locations, as well as the foundation size. So you'll find that here for the base plate, it is connected to the member column. So that is, this is my member, that is HEA300. And for the base plate, we considered a material grade of S275. The thickness is 20 mm, and all the dimensions of this base plate will be provided as per that profile with respect to the profile of the column. Now coming to the offsets, here we define the various offsets required to define exactly the geometry of the base plate. And as you can see that coming to the anchors, we have used M20 8.8 class bolts, and the anchor length considered, that is this total length considered, is 400 mm. And at the end of the anchor rods, we considered the washer plates of dimension 100 by 100 square plates. Now coming to the layout of this positioning of the anchor bolts are done using the definitions of the top layers, left to bottom, as well as the right layers. And it is assumed that the shear plane will be considered in the threaded portion. Now the wells are defined, as you can see that here it is very clear. In both cases we have used the fillet wells with a size of 6 mm for the connection to the web of the column and an 8 mm size for the flanges. Now for the foundation concrete, we have considered a C2530 as per EC2, and for the offset we considered an offset of 500 mm all around the base plate. The depth of the foundation considered is 1000 mm, and the shear force transfer is considered to be through the friction. That means no shear will be taken by the anchor bolts, and we considered a mortar joint below the base plate of thickness 20 mm. So that's the first one was regarding the definition of the column through the members, and the second was the definition of the base plate as well as the anchor bolts through the manufacturing operation base plates. And now coming to the load effects, here you will find that I have defined 4 load effects: LEP0, LEP1, LEP2 and LEP3, 4 load effects. And in fact these load effects corresponds to 4 points on the interaction diagram. These points are P0, P1, P2 and P3. Now let me just show you what are these load definitions. First, coming to the LEP0, here you will find that the base plate is subjected to only a tensile force of 235 kN. So you may ask me, how did you start with this force 235? So the best answer is you prepare a rough calculation as well as the code provisions, and then start with this value of tension obtained from the hand calculations, and at the same time see the utilization ratio in the IDEA StatiCa. Accordingly, either increase or decrease the value so that the utilization ratio will be approximately 1. This is how I arrived at a tensile force of 235 kN. And so here you will find that all other forces are set equal to 0. Now coming to LEP1, so here we find that LEP1, it corresponds to a case wherein the column will be subjected to only a moment My of 120 kN. So in P0 we have got only tension, and in P1 we have only the moment. Now coming to P2, as you can see that it is a case wherein both an axial compression as well as a moment is applied, with an axial compression of 800 kN and a moment My of 200 kN. And now finally coming to the LEP3, that's a load effect corresponding to the point P3. Here you will find that the base plate is subjected to only an axial compression of minus 2400 kN. So we will run the IDEA StatiCa model for all these 4 load cases, and then we will arrive at the distribution of the forces in the anchor bolts, the distribution of the bearing stresses below the base plate, and also the safety concerning to the base plate as well as the connecting members, connecting columns, etc. So what I can do is that, for example, I can just tick all these load effects so that the program will run it for me. Okay, fine. So you can just press the calculate button. Fine. So the output results are displayed over here, and this is for LEP0, wherein you will find that the column is subjected to only axial tension. So if you want to see the stress distribution in concrete, so here you will find that there is only the edges in contact, and in a similar way you can also find out the stress distribution for other combinations P1. So we can just press here. So here we can see that this is the load distribution. This is the bearing stress distribution in concrete for P1, and you can select, for example, a combination P3 wherein there is a maximum compression. So we can also evaluate the stress in concrete. So this is the bearing stress in concrete. So we will review all these results in detail in the presentation. So let me take you back to the presentation. Okay, so the PM coordinates obtained from the IDEA static analysis are used here for the development of the PM interaction diagram. So the diagram obtained for the present column base plate is readily shown over here. So you can see that the axial load peak in kilonewton, it is plotted along the x-axis, and the associated bending moment M in kilonewton meter along the y-axis. So of the various points, you can see that some points are readily identified over here that corresponds to the load cases we investigated in IDEA StatiCa. For example, P0, that is a point on the x-axis, it corresponds to pure tension, and then P1 is a point on the y-axis that corresponds to the pure bending moment applied, and P2 is a case wherein the column base plate is subjected to a critical combination of both P and M, and finally P3 is another point on the x-axis that corresponds to a pure compression case. Now let me take you to the analysis details corresponding to these 3 points P0, P1, P2 and P3. Okay, fine. For the point P0, we find that the column reaches its critical design resistance. That's a column base plate is critical, corresponding to a tensile force of P equal to minus 235 kilonewton. That means the column base plate is subjected to a tension load of 235 kilonewton. Now let us investigate the results. So here is shown the distribution of the bearing stresses below the base plate. Obviously we know that under the pure tension we don't expect any kind of a base plate contact with the pedestal. However, as there is an effect known as the prying, we notice that some edge portion of the base plate, it is in contact, and therefore we get some kind of a pressure distribution at the edges of the base plate. However, this pressure are not critical. We find that the maximum value is of the order of 8.7 MPa. So for this case of applied pure tension, the various analysis results, a summary is present over here, from where we can find that the critical value of the tension T equal to 235 kilonewton, it is governed by the anchors, and the corresponding utility ratio is of the order of 99.8, which is less than 100%. And here obviously the plates and the concrete blocks, they are not going to be critical, because we know that the concrete block is theoretically not in contact with the plate. So now let me take you to another point, that is a point P1, wherein the base plate is subjected to only a moment. Accordingly, the point P1 will be 0 kilonewton, that is a P value, and a moment value of 120 kilonewton. So the results are present over here, and obviously you will find that when a pure moment is applied, an edge portion of the base plate will be obviously in contact with the grout, and we find that the tension forces are getting developed in the anchor bolt. So here we find that again the bearing stresses are not critical, because the bearing stresses are of the order of, hardly we can say that of the order of, say it is between 10 and 8 MPa. These are the low values as far as the C25, C30 concrete is concerned. And now the analysis results are plotted over here. Here again we find that the anchors are of the again a governing criteria that is utilized to 98.6%. Obviously this is less than 100%. And here again we find that the concrete block is also critical, that is of utility ratio is 0.85. Now this is the distribution of the bearing stress below the base plate for P1. Now in a similar way, let me take you to the P2, wherein we find that the column base plate is subject to an axial load of 800 kilonewton and a moment of 200 kilonewton meter. So the results are presented over here. Here again we find that coming to the distribution of the bearing stress below the base plate, it is critical because we find that it has reached almost a peak value of 32.5 kilonewton MPa, because it's subjected to both axial load as well as the moment value. And here again we find that the anchors are also subjected to tension, but they are not critical. And here obviously we find that the critical the component is a concrete block, that is 99.3 utility ratio, that is less than 100%. So this is the distribution of the bearing stresses. It is very clear that as expected, the bearing stresses are concentrated in a region very near to the most compressed edge of the column flange. Now finally, taking you to the result of a point P3, which corresponds to only a compression load of 2400 kilonewton applied out to the column. So this is the distribution of the bearing stress below the base plate. Here again we find that obviously first observation is that there are no anchor bolt forces. They are not subjected to any tensile forces because the base plate is under pure compression. And we find that the design is governed by the concrete block, wherein a utility percentage of 98.5, which is less than 100%, is observed. And again here we find that the bearing stress distribution below the base plate, it is almost following a pattern similar to the one that is shown in EC3 part 8. And here again we find that the bearing stresses below the base plate are critical, and that is almost 29.4 MPa. That's very close to the bearing strength of the concrete. So that's all the summary of the results that we observed from IDEA StatiCa, and hope that you have liked this presentation. And as usual, please go ahead and subscribe. If you have any comments and queries regarding this presentation, please let me know. So thank you and have a nice day.